questions that we can expect from the geotechnical engineering in the assistant engineer's point of view. So basically it's a diploma level, and first of all let's see from the geotechnical engineering what is the syllabus that has been given. So the syllabus for the assistant engineers, so you don't need to go through the entire 19-20 chapters that you have prepared for the AEE. So for the AE assistant engineers, and if you haven't seen the syllabus has been included in the transportation engineering under the part 2. So there are 7 topics that has been included in the assistant engineers syllabus. Those topics are types of soils and its origin, and properties of the soils. So all the properties, physical properties, index properties, and engineering properties also, but specifically the properties of soil, here I am discussing about the physical and index properties and soil classification. And coming to the engineering properties, permeability and corresponding stresses, they are also the basic level only. And then compaction, consolidation, those two comes under the property known as the compressibility. And from the foundation engineering, only bearing capacity, which means shallow foundations. So the people who have completed the recent AEE examination, so you might have prepared the seepage pressure, seepage analysis, shear strength, earth pressure theories, stability of slopes, pile foundations. You don't need to study all those things. So this is the, but whereas based on the transporting agents, again there are different type of soils. So based on the transporting agents like air or wind, alien deposits. And in the case of the water, again in water, lake, lacustrine deposits, and river water, alluvial deposits, whereas marine water, marine deposits. And we have discussed about the examples in the class sessions, and if you have attended the online sessions, so you might have covered those origin of soils also. Okay, so based on the geological cycle, first wind, alien deposits, water, and then gravity. For the gravity, colluvial deposits, glacier deposits. Okay, and then we have discussed about the different type of soils there, which is nothing but the loamy soil. Loamy soil is a mixture of the sand, silt, clay with almost equal proportions. Carriage, it's a mixture of the gravel, sand and silt. Warped clay, it's an alternate thin layers of the clay and silt. So that's a warped clay. Whereas a bentonite clay, it's a form of the clay soil. So it's a chemically weathered residual deposit and has a very high swelling, shrinkage and plasticity due to presence of the montamolinite clay mineral. Because in the case of the clay, there exist 3 minerals, coelinite, illite and montamolinite. So out of these 3 minerals, the montamolinite has a high swelling, shrinkage and plasticity due to presence of the water bond between the lattice structures. Okay, so that's about the chapter number 1, origin of soils. And coming to the properties, that especially in the case of the physical properties, so the questions that we can expect is nothing but from the basic definitions. The basic definitions are from the void ratio, porosity, degree of saturation, water content, air content. So these are the basic definitions, and then we discussed about the unit weights. So there are various type of unit weights, and then specific gravity. There are 2 type of specific gravities. One is true specific gravity and other one is apparent specific gravity. And then we discussed about some of the basic relations. So you don't need to go too much into this chapter also. Now let's see the questions. The relationship between the bulk density, dry density and the water content. So what is the relation between over here is out of the 6 functional relationships, I have mentioned you gamma D is equals to gamma by 1 plus water content. So let's see out of the given options which is the nearest one. So gamma is equals to gamma D into 1 plus W. The option A itself is a correct answer. So now let's forget about the remaining things and directly go for the next question. So now coming to the warped clay, just now we discussed about warped clay. It's an alternate thin layers of the clay and silt, and we do see this warped clay at the bed of the lakes. It's an example of the lacustrine deposit. So it's an alternate thin layers of the silt and clay. Oceans, right? So we do construct majority of the structures which is nearby, the bridges and all, dams and all, the hydraulic structures we do construct in the rivers, so alluvial soil. From the given options, the correct answer is alluvial soil, but basically marine soil also comes under the water formed transported soil. Okay, next the relationship between the void ratio and porosity. So there is a relation between the void ratio and porosity. N is equals to E by 1 plus C. Or sometimes they can be asked in a different way, either this option or E is equals to N by 1 minus N. Any one of this option is present here, so that's going to be the correct answer. So here N is equals to 1 plus C, no. E is equals to 1 plus N, no. So n is equals to E by 1 plus C, n is equals to E by 1 plus C, then you can take this 1 plus C to the other side. So E is equals to n into 1 plus C. Option C is the correct one. So if you see, this is a relation between the void ratio and porosity. And then a fully saturated soil is said to be. See, based on the moisture content, there exists three states: a fully saturated, partially saturated, and dry state. If it is a fully saturated, entire voids are filled with water and solids. If it is a dry state, entire voids are filled with air, and the remaining component is nothing but the solids. And if it is a partially saturated, there will be water, air, and then the solids. So given is a fully saturated, and the fully saturated consists of two things. One is water, and other one is solid. How many components are there? Two. So two phases. It's not a one phase system. It's a two phase system with the soil and air. No. Soil and air means a dry state. It's a two phase system with the soil and water. Yes. A three phase system. Three phase system is a partially saturated. Three phases means three components. Next, water content of a soil can be. Mind you, out of all the relations, so whatever the void ratio, porosity, degree of saturation, air content, percentage air voids, and water content. So the people who are preparing for the assistant engineers, from the past trend, majority of the questions has been appeared from the properties of the soil only. But we never know, the same trend can be obtained for the next examination also. But given that, they used to ask majority of the questions from these basic definitions, the definitions of this one, their ranges, and the relation between those components also. Now one of these questions is about the range. Water content of the soil can be. Water content can be any value. It can be 0, it can be 100, it can be more than 100. So greater than 100%, less than 0, no. Only from 0 to 100, no. It can be more than 100. Never be greater than 100%, no. From the given options, it can be greater than 100%. So, but basically it has to say can greater than 100% from the given options. Okay, so void ratio of a soil mass. Just now I said you the void ratio. So for remembering of all these basic definitions, you remember by means of the phase system. So what is void ratio? Voids to the solids. Volume of, and given it's again range, never be greater than unity. So you know void ratio can be any value except 0. It can be any value except 0. So never be greater than unity, no. Be 0, no. Take any value greater than 0, yes. Void ratio can be any value except 0. Next, the porosity of the soil sample having its void ratio equals to unity. So just now we have discussed void ratio is equals to 1, then what is the porosity? N is equals to E by 1 plus C. So 1 by 1 plus 1, which is equals to 1 by 2.5. But that's a decimal, right? You have to convert into percentage. It is going to be 50%. So from the given options, the correct answer is going to be 50%. Okay. Next, a soil has a volume of 100 centimeter cube and mass of 200 grams. Okay. So soil, see, they just mentioned a soil, which means it's a natural state, which is partially saturated. So volume is there, and just its weight is given as 200 grams. Come on oven drying for 24 hours, the mass is reduced to 100 grams. So the dry weight is equals to 100 grams. Calculate the dry density. What is the dry density? It's a basic question. Dry density is nothing but dry weight by volume. What is the dry weight? 100 grams by what is the volume given? 100, which is nothing but 1 gram per cc. But that is in terms of gram per cc. But you see the units here, this is in terms of the kilometer per meter cube. And you know 1 gram per cc is nothing but 9.81 kilometer per meter cube. So answer is going to be 9.81 kilometer per meter cube. So they're asking about the dry density. Answer is going to be 9.81 kilometer per meter cube. That's an option A. So in the same question, I can give you the void ratio. I can give you the specific gravity. I will ask you the void ratio. If I give you the specific gravity, suppose if I give you some specific gravity as 2.7 in the given question, I'm just modifying the question. If I give you the specific gravity 2.7 and I'll ask you the void ratio, then what to do? So there is a relation between the gamma d, G gamma W by 1 plus C. You have to get down this E value as G gamma W by gamma D minus 1, right? So you know the G value 2.7. And anyways, gamma W, you can go with the directly gram per cc, gamma W 1 gram per cc, gamma d 1 minus 1. So answer is going to be 1.7. If I would have asked you the wide ratio, you have to approach this way. But in this question, I'm just asking you how to find out the gamma d. So there is option A. So I hope you can understand this relation also. Now let's see this question. A soil deposit has a water content of the 15%. Specific gravity G. Wide ratio is given. Calculate the degree of saturation. The relation between the W, G, E and SR. Sehwag, J below Sehwag. So I told you this is the first and foremost equation that you need to remember in the case of the properties of soil. So what they're asking is the degree of saturation. Just simply insert everything. SR is equals to, water content is nothing but 15% means 0.15 into G value. The G value is 2.5 by, this is 0.5. So if you solve it, it's going to be like 0.75, which is nothing but 75%. 75%. The degree of saturation is 75%. You can explore this question much further. See, in this question, I gave you water content, specific gravity and wide ratio. I asked you the degree of saturation. But suppose if I ask you the same question as a fully saturated deposit. A fully saturated deposit has a water content 15%, specific gravity 2.5. Then what is the wide ratio? So I already mentioned you the fully saturated. So then SR I have given, W and G is there. You can find out the wide ratio. Out of the 4, I give you 3, you can find out the 1. So 4 parameters, you can frame 4 different questions. Sehwag. And in the previous question, we have discussed about the gamma d and all, right? Now, the similar type of question, a soil has a volume of the, again, 100 centimeter cube and mass of 200 grams. On oven drying for 24 hours, the mass is reduces to how much? 150 grams. Calculate the water content. Now, you see, in this question, I asked you the wide ratio. Now, this question they're asking the water content. So, how to find out the water content? Water content is nothing but weight of water by dry weight of the soil. What is the weight of water? Initially, how much? 200. Final, how much? After oven drying, 150. How much reduced? 50. Who is that? Water only, right? So, initial weight, 200 minus final weight, 150 by, what is the dry weight? 150 into 100. So, this is 50 by 150 into 100, right? 50 by 150 means this is going to be 3. 100 by 3 is nothing but 33.33%. So, the answer is going to be, the near well is 33%. Okay. So, now the relation between the ratio between the wide ratio, degree of saturation, water content and specific gravity. You know that. Sehwag. E into S is equals to W into G. Now, if the plasticity index, so these are the questions that has been appeared from the, these are the previous AE questions and some of the AE level questions. Okay. So, if you observe here that basic definitions, the relations are the important ones. We don't expect much of the numericals for the diploma level, but if they have given the numericals also, that's of, one cannot expect that. So we have to prepare in all the corners, okay. Now, let's see some of the questions regarding to the physical properties and then index properties of the soils also. If the plasticity index of the soil mass is 0, then the soil is said to be. So what is a plasticity index? You know that from the consistency chart. So the consistency chart goes like this. Up to shrinkage limit, there is no change in volume. And then beyond that, as moisture content increases, the consistency of soil changes. So state of soil will be changes. So here it is a solid state, and this is semi-solid state, and this is going to be the plastic state, and here it is going to be the liquid state. Okay. So what is this? Shrinkage limit, plastic limit, and liquid limit. Out of all the parameters from these consistency limits, the plasticity index is very, very important. What is the plasticity index? It represents the plasticity nature of the soil mass. That simply, it's a difference between the liquid limit and the plastic limit. Suppose if the difference, whatever the difference, IP is equals to WL minus WP. If the difference is 0, what is the meaning of difference 0? There is no plastic state. Then you can term that soil as a non-plastic soil mass. So, if the plasticity index is 0, then the soil is non-plastic. Out of these soils, who is non-plastic? Sand is the non-plastic. See, we have different soils, gravel, sand, silt, clay. Gravel and sand are considered as a coarse grain soil, which does not have any plasticity. Whereas sand, in the case of sand, fine sand, silt and clay, they are going to be considered having some plasticity. Whereas clay has the highest plasticity, silt has the least plasticity. Okay. So the answer from the given answers, it is going to be sand. Now, which of the following has a more plasticity index? Obviously, finer the soil, more the plasticity index. Out of all the soils, the smallest size is the clay. So clay will be having a more plasticity index. Next, a relative density of a compacted dense sand is approximately. So relative density, we know that relative density ID is equals to E max minus E by E max minus E minimum into 100. So E max minus E by E max minus E minimum into 100. Okay, so based on the relative density, we can say whether the given soil is dense or loose. 0 to 15% very loose, 15 to 35% loose, 35 to 65% medium, 65 to 85 dense, and more than 85 highly dense. So now from the given options, it's not 0.95, it's 0.75. The relative density of a compacted dense sand. Compact dense means very dense state. So obviously more than 85% highly dense. The given option 0.95, which means 95%. Okay. Next, consistency as applied to the coastal soils is an indicator of its. What is meant by consistency? Consistency or stiffness. So that represents the resistance against deformation, right? So you add more water, consistency will be decreases. The consistency represents the strength of the soil, and that strength keep on decreases by adding more moisture content. So consistency as applied to coastal soils is an indicator of its density, no. Moisture content, no. It's a strength. It's a strength. Consistency represents the shear strength of the soil. Okay. A soil having particles of nearly same size is known as. See, in the case of the dry sieve analysis, if you observe, so once we draw the particle size distribution curve. In the case of the particle size distribution curve, once we draw the curve, percentage finer on x-axis log scale, we can expect three forms of the graph. The graph number 1. So that represents the well-graded soil. What is the meaning of well-graded soil? So in this graph, the graph is a continuous graph which starts and ends over here. It is covering almost all particle sizes. So if the soil has almost all sizes, then we can call it as a well-graded. And if you see the graph is going to be almost or nearly vertical, that means very small sizes, very small number of sizes are going to be present. So this form of graph, we call it as a uniformly graded, where almost all particle sizes are same. And there is one more graph where we can see the graph comes with a hump. So a rise and then horizontal and then rise. So this form of graph, we call it as a skip graded or a gap graded, where some particles are missing. If almost all particles are present, well graded. Almost all particles are same, uniformly graded. Some particles are missing, gap graded. So a soil has a particles of nearly same size. Nearly same size means almost all particle sizes are same. So from the given options, it is a uniformly graded. And when it is going to be well graded, I have already explained you. Okay. Now, a well graded soil has a coefficient of curvature between. See, you know that the dry sieve analysis is suitable for the coarse grained soils, whether it is a gravel or sand. For well graded soil, the CU must be in between 1 to 3 and including 1 and 3 also. So the correct answer is going to be 1 to 3. Now, among the clay minerals, the one which having the maximum swelling tendency is, as I already mentioned you, clay has 3 different type of minerals: kaolinite, illite and montmorillonite, whereas halloysite is a dry form of the kaolinite. But basically we discussed about kaolinite, illite, montmorillonite. Based on the bond between the clay particles, the properties of the mineral is going to be changes. Out of all the particles, the maximum swelling tendency is present in the case of the montmorillonite. Why? Because in case of the montmorillonite, between two flaky particles, clay particles, the bond is water bond. So from the given options, it is going to be montmorillonite. If they would have asked the question as the one having the least swelling tendency, then we have to go for the kaolinite. Kaolinite has the strongest bond, whereas the montmorillonite has the weakest bond. Next, a soil has a liquid limit of 40% and plasticity index of 20%. The plastic limit of the soil is. So liquid limit is given as a 40% and plasticity index is given as a 20%. What is the plastic limit? You know that IP is equals to WL minus WP. So the plastic limit is equals to liquid limit 40 minus plasticity index 20. 40 minus 20, so the answer is going to be 20%. The answer is going to be 20%. Not only about the plasticity index, you can expect the similar type of questions for the consistency index, for the liquidity index also. They will be giving, along with the liquid limit, plastic limit, they will be giving you the natural moisture content. So once they give you liquid limit, plastic limit, natural moisture content, we can find out the liquidity index and the consistency index also. But majority of the questions has been appeared from the plasticity index itself. So anyways, you have to go through those equations also. Okay. So now the liquid and the plastic limit exists. The liquid and plastic limit. This liquid and plastic limit is nothing but the Attapag limits, right? So Attapag limits are going to be exist for soils finer than 425 micrometers. First of all, we can eliminate sand, we can eliminate gravel. And again, clay and silt is there. Though we say for finer than 425 micrometers, but anyways, all the time we discuss about the clay, because clay is the one which is formed by chemical weathering. Due to chemical weathering, it has a charge. So you know the clay particle is a flaky particle which has a negative charge on the face and positive charge on the edges, right? So when we discuss about the plasticity, swelling, shrinkage and all characteristics, we do deal majorly the clays, not the silts. So the correct answer is option D. Okay. So now let's see this question. For a soil, the water content where further loss of moisture will not result in the volume reduction. You just go back once again where I have represented you the consistency chart. If you see this consistency chart, in this consistency chart, if the moisture content decrease, volume will decrease. So this is the volume, right? Volume will decrease. Up to whom? Up to shrinkage limit. And once it crosses the shrinkage limit, though the moisture content reduces, volume remains same. So what is the minimum water content where there is no change in the volume for further loss of moisture is nothing but the shrinkage limit. So the correct answer for this question is, the correct answer for this question is going to be the shrinkage limit. The property of a soil which allows it to be deformed rapidly without rupture. So what is the ability of a soil to deform without any rupture, without any failure? That is known as plasticity. From the given, yielding, strain softening, strain hardening and plasticity. What is the plasticity? Ability of a soil to deform freely without any failure. It's just like a chapati. So when you are going to prepare the chapati, when you add the water, sufficient water to the atta powder, you make some paste. Then you are going to roll into different shape, right? Whatever the shape that you are deforming freely, right? That is nothing but the plastic state, okay? So these are some of the questions regarding to the physical properties and index properties. Mind you, you have to be given a very careful attention for this chapter, both physical properties and index properties. Based on the diploma level, based on the previous pattern, majority of the questions has been appeared. That doesn't mean that there is no other question from the other chapters also. There are some questions from the other chapters too. But we have covered each and every topic majorly from these two chapters. And then let's get into the soil classification. So in the case of the soil classification, so we have a different type of classifications, but we follow now as ISCS, Indian Standard Soil Classification System. As per ISCS, total number of groups are 18. Okay, so in that 18, for the coarse grain it is 8, for fine grain it is 9, and apart from that a pure organic soil, that's going to be 1. And in this the major questions that you can expect is from the plasticity chart, which means about the fine grain soils. So now let's see this question. Based on this question we can say the inorganic soil with a low compressibility is represented. See, the compressibility component will be attained only for the fine grained soil. So now, if you go with the plasticity chart, so this plasticity chart was given by the Casagrande, where a straight line is passing at an intercept of 20%. So this line we call it as a line. And whatever the soil that lies above a line, we say it as a clay. Whatever the soil below a line, we say it as a silt. And based on the compressibility, the soil can be divided into three compressibles: low compressibility, intermediate compressibility, and high compressibility. 35%, 50%. Okay, so based on these values, 35, 50. Okay, now less than 35% is going to be low compressible, 35 to 50 is intermediate, and more than 50 is a high compressible. So above the A line, that's going to be the low compressible clay. Below is nothing but the intermediate, means low compressible silt for the 35%. So low compressible clay, we call it as a CL. Do always remember, when they give you the CL or when they give you the condition, how you are going to represent the symbol. Always, for example, low compressible clay, when you say the name first to last, the symbol should be last to first. Low compressible clay, symbol CL. And intermediate compressible clay, high compressible clay. Similarly, low compressible silt, intermediate compressible silt, and high compressible silt. Okay, now they are asking the inorganic soil. Clay and silt are inorganic only. Inorganic with low compressibility. Low means L. If you see here, MH, H is nothing but high compressible. No. SL, this L is nothing but low compressible. But low compressible, S means a sand. No. Sand does not have compressibility. Who will be having the compressibility? Fine grained soils. And now coming to the ML, yes, low compressible silt. Low compressible silt. So ML is there. So the correct answer is going to be the option C. And whereas CH, again H is there, high compressible, so it's not going to be the correct answer. The correct answer is option C. Now, as per IS soil classification, the clays, organic soils are represented by. So as per IS classification, the organic soils are represented. It's not a clays. So organic soils are represented by. If you see the organic soil, out of all these things, the only thing is O, organic. Now if you go to the plasticity chart, sometimes in examination they will give you the organic also. The organic matter will be fall below the A line only, but at the bottom, OL, OI, OH. As they clearly mentioned about the organic, so out of the given options, the organic is going to be only O. So they are asking about the organic soils. So OH means a highly compressible organic soil. The correct answer is option D. Okay. Next, as per IS soil classification, gravelly soils more than half of the grains larger than IS sieve size. Sieve, this is a sieve number 480. What is IS sieve number 480 means? 4.75 mm. See, whatever the soil that retained on the 4.75 is nothing but the gravel. What they are saying is, if it is a IS sieve 480, it is a 4.75 mm sieve. Majority, more than 50% of the soil is retained. If more than 50% of the soil is retained, then the percentage of the gravel, so whatever the passing is going to be less than 50%, right? The percentage gravel will be more than the percentage sand. So who is a major soil? Gravel. Already they have mentioned that gravel soil. And you see the options over here. So GM, GL, GS and SM. First of all, we can eliminate D. And you see C. What is GS? Sandy gravel. No. Either gravel or sand. You cannot use both. Eliminate. And GL. What is GL? Low compressible gravel. Whereby compressibility does not come for the gravel. See, when they give you the questions, you have to go to the elimination procedure. So GL is not possible. The only answer is GM. The correct answer is GM. Okay. So these are some of the questions regarding to the plasticity chart for the classification of the soils. And so it's a classification. We can see this. Okay. So now come to the permeability and effective stress. Which one of the following diagrams represents the effective pressure distribution for a saturated soil mass of depth Z, submerged under water of height Z1 above its top level, gamma sat. Okay, so which one of the following diagrams represents the effective pressure distribution for a saturated soil mass of depth Z, submerged under water of height Z1 above its top level? Okay, so if this is a ground level, above this one there is a water level of height how much? Z1. What they are asking is, if that soil is completely submerged, so they have given the unit weight gamma sat like this. What is the effective stress distribution? You know that effective stress is nothing but the stress transferred from one grain to another grain. And if there is a water above the, if there is a water, if there is a water, so if there is a water above the ground level, obviously, so if there is a water above the ground level, it is not going to be cause any effective stresses. Okay. మరి రేపు చెప్దాం. Sorry for the interruption. As some of our students, they are asking about the objection videos, I mean, regarding to the AEE. So whatever the mistakes, some of the mistakes obtained from the AEE key, so they are requesting for the objection videos. So for you, tomorrow we are going to provide a live session. So it will be announced either in the afternoon or in the, it will be either in the evening or afternoon. So don't worry, whatever the questions that you can be challenged to the state services, or what are the questions that you have still doubt, we are going to discuss about those questions in our tomorrow. So don't worry about that. Right now we'll be focusing on the AE. Okay. So apart from that, there are not much of the questions. Okay. Yeah. So let's go further. So now this is a condition over here, above the ground level, the water table is there, and water depth is nothing but Z1. So you know that in this Z1, there is no solids. When there is no solids, then there is no effective stress. And if you draw the pressure distribution for the effective stress, at the top, up to ground level, there will be no effective stress. Below ground level only effective stress is there. And as it is a submerged, then the unit weight is going to be gamma dash into Z. So this is how the effective stress pressure distribution should be there. Sir, why there is no variation, sir, here? Because above ground level there is no water, sir. So below ground level only there is above ground level there is no solids. Below ground level only entire soil is submerged. So now you see the options. So these are the options where you observe over here. So this is Z1 and Z, and where it represents this is a gamma dash. That's a gamma dash. And you see here, so above Z1 water table, it's not going to be happen. And this is a surcharge concept, no. And this is the one where it is given as a gamma sat, where this is given as a gamma sat. This is gamma dash. You see option A and option D, both the distributions are same. But what is the stress distribution they are asking? Effective stress. If it is effective stress, we have to use gamma dash. If it is a total stress, we have to use gamma sat. So out of these two, the correct answers are option A. Okay. Now, the soil at a site consists of two layers. So coming to the permeability, in the case of permeability, what is permeability? Ability of a soil to permit water through the interconnected void spaces. We know different soils have a different permeability. Out of all the soils, gravel has more permeability and clay has the least permeability. So in order to determine the permeability, we have a law known as a Darcy's law. So as per Darcy's law, how to find out the seepage flow rate is nothing but Q Kia. Q is equals to KIA. So, but in order to find out this K, we have done some lab experiments. But in reality, soil will never be homogeneous, soil will never be isotropic, soil will be a stratified deposit. So in the case of the stratification, suppose if you take two different soils, depth Z1 and Z2, permeability is K1 and K2. And when there is a flow, the flow can either pass vertically or horizontally. So what is the meaning of vertical and horizontal over here? So the boundary between the different layers, we call it as a bedding planes. We call it as a bedding planes. When the flow is going to be perpendicular to the bedding planes, the condition will be different. When the flow is parallel to the bedding planes, the condition is different. When the flow is perpendicular to the bedding planes, then the average permeability is Ky. How to find out that Ky, sir? Is nothing but summation of that Z by summation of Z by K. That's going to be the Ky. And when the flow is going to be parallel to the bedding planes, the average permeability Kx is equals to summation of K into Z by summation of Z. Summation of K into Z by summation of the Z. And out of these two, always the Kx is going to be more than the Ky. What is Ky? Average permeability when the flow is perpendicular to the bedding planes. What is Kx? Average permeability when flow is parallel to the bedding planes. So now from the given options, soil at a site consists of two layers. The top layer has a permeability K units and bottom layer has a permeability 5K. So from the given, the top layer is given as a K and bottom layer is a 5K. Two layer deposit only. And the thickness of both layers is same. So Z1 is Z, Z2 is also Z. Then what is the average permeability in the vertical direction? In the vertical direction means you have to take the Ky value. So now if you see the Ky is equals to, as I said, summation of Z, right? Z1 plus Z2. Both are same, right? So summation 2Z by, so summation of the Z by K. Summation of Z by K means Z1 by K1, Z2 by K2. Right? So now come on, tell me the value. So Z1 by K1, what is Z1? Z K, Z by K plus Z by 5K. Right? So you can take the Z by K outside. If you take the Z by K outside, Ky is equals to 2Z by Z by K outside 1 plus 1 by 5. So now Z will get cancel and the K will go to the numerator. You take out the LCM 1 plus 1 by 5 which is going to be how much? 6 by 5. So the 5 will go to the numerator which is going to be 10 by 6K. What is 10 by 6K? 5 by 3K. So the correct answer is going to be 5 by 3K units. Either they can ask you average permeability in the vertical direction or they can ask you average permeability in the horizontal direction. So if they ask horizontal, this is the equation. If they ask vertical, this is the equation. Okay. From the given options, the answer is going to be 5 by 3K. Okay. Now let's see this question. The property of a soil which permits water to percolate through it. What is the property of soil to permit water? That's nothing but permeability. So the correct answer is permeability. What is capillarity, sir? Capillarity means ability of a water to rise against the gravity. Ability of a fluid to rise against the gravity. So that's a fluid property. And now a soil has a discharge velocity of the V to 6 in 10 power of minus 7 meter per second and void ratio 0.5. Its a seepage velocity is. As we know from the Darcy velocity, Darcy Q is equals to KIA, where the velocity is equals to KI. But that velocity is not actual velocity because we have taken the total cross section area. The actual velocity is a seepage velocity. So as per Darcy, from the Darcy relations, if we get the seepage velocity is nothing but V by N. So they have given the discharge velocity, they have given the void ratio. But in order to find out, we require the porosity, right? So how to find out the porosity? N is equals to E by 1 plus C. So 0.5 by 1 plus 0.5. So N is equals to 0.5 by 1.5. We can directly write as 1 by 3. Just leave it like that. We can see the remaining thing later. Now coming to the seepage velocity. What is seepage velocity? Discharge velocity by porosity. So the discharge velocity 6 into 10 to the power of minus 7 by 1 by 3. That's going to be 18 into 10 to the power of minus 7 meter per second. 18 into 10 to the power of minus 7 meter per second. From the given option, the correct answer is option E. Okay. Now, a phreatic line is defined as the line within a dam section below which the pressure is. See, the phreatic line means the topmost water line, or just simply, for example, if there is a ground level, whatever the water table is there, right? This line we call it as a phreatic line. It's a topmost flow line. And below the water table, always the pressure is a hydrostatic, positive hydrostatic pressure. So below water table, pore water pressure is a positive. Above water table, pore water pressure is negative. That too, if there is a capillarity. If there is no capillarity, then pore water pressure is 0 above water table. So always below water table, water pressure is positive. It's a positive hydrostatic pressure. So option A is a positive hydrostatic pressure. Now, so these are some of the questions where you have to look from the permeability and stresses. So do remember, in permeability, the type of models we can expect is from the Darcy's law. They can ask the theoretical questions from the Darcy's law also. Darcy's law is valid for whom? The soils which are finer than 425 micrometers. What are those soils? Fine sand, silt, clay. As per Darcy's law, the flow should be laminar. What is the Reynolds number for the laminar flow? Re less than 1. Mind you, this is also one of the previous AEE question, means the last month. So whatever happened AEE, in that question they have asked about the Reynolds number. So for that also they have given a wrong key that we'll be discussing in the tomorrow. But Darcy's law is valid when the flow is laminar, and for that the Reynolds number should be less than 1. Okay. So those are the type of questions that one can expect, and the numerical wise we can expect the CPS velocity and Darcy velocity relationship. And apart from this, you can expect a question from the tests. Which of the following tests is going to be suitable for finding the or for determining the permeability of coarse grain soil? For coarse grain soil, we always go for the constant head permeability test. For fine grain soil, we always go for the falling head permeability test. For saturated clays, we go for the consolidation test. And for large engineering projects, pumping out tests. For small engineering projects, pumping in tests. Those are the tests to determine the permeability. Apart from that, they can ask you what are the factors affecting the permeability. So the various factors affecting the permeability is equals to K directly proportional to D10 square, effective size, where D10 is nothing but the effective size, and K is directly proportional to E cube by 1 plus C. So where void ratio, K is directly proportional to gamma F by mu. So when temperature increase, the viscosity will decrease. When viscosity decreases, permeability is going to be increases. Those are the questions that we can expect from the permeability. And coming to the effective stresses, see, without knowing the stress, we cannot go for the consolidation or compaction. So I just have given some questions of the stresses. That stresses is not present in your syllabus. But anyways, if you do know the basic, that's fine. Okay, so for the stresses, we have already discussed about what is the effective stress and how you are going to get it done. Total stress, pore water pressure and effective stress, you just go through those. But as per the syllabus, it's not required. Okay. Now, let's see the questions from the compaction. So in the case of the compaction, majority of the questions will be the theoretical only. So in compaction, what is compaction? It's a process of reduction volume by expulsion of the air. Can we eliminate 100% of air? No, we cannot eliminate the 100% of air. Why? Because during compaction, we apply the load, we remove the load. Apply the load, remove the load. It's a dynamic loading, it's not a static loading. So 100% elimination of the air or expulsion of air is not going to be possible. So first of all, we have to fix what we need to know or what we need to find from the lab. Then only we have to go for the field to do the compaction. Always we compact the soil prior the construction of any structure, right? The purpose of the compaction is to improve the strength, to reduce the permeability, to reduce the swelling, to reduce the settlements. Okay. So now the coarse grain soils are best compacted. Coarse grain soils are all the cohesionless soils are best compacted by means of the smooth wheel roller. See, there are different type of rollers, and those rollers based on the type of soil we use. For cohesionless soil or coarse grain soils, we always go for the smooth wheel rollers. For clayey soils, we always go for the sheep foot roller. And for the soils, if it's a mixture of the coarse and fine grain, we go for the pneumatic tire rollers. And if it is a gravel and sand in dry form, sand in dry form, so there we go for the vibrator rollers. So now the drum roller, a rubber tire roller, sheep foot roller. So whatever the drum roller, that's nothing but the smooth wheel roller. What is the meaning of rubber tire roller, sir? Rubber tire roller is nothing but the pneumatic roller, pneumatic tire roller. Okay, rubber is nothing but that rubber tire means that is going to be gives a pressure. So pneumatic. Next, the degree of compaction for sand is usually defined in terms of, see, compaction curve is not well defined for the sand. So as a compaction curve is not well defined for the sand, so instead of representing relative compaction, we have to depend upon relative density, ID, relative density. Standard Proctor test, modified Proctor test, nuclear density meter. The compaction curve for the sand, if you see, in the case of the sand, the compaction curve first decrease and then increase and then decrease. It's not well defined. Sir, why the curve is like this, sir? Because due to bulking of the sand. Due to bulking of the sand. For sand, its a density, its a compaction is a better related by means of relative density, not relative compaction. A line which shows the water content dry density relation for the compacted soil containing no air voids. Whatever the no air voids, nothing but zero air void line, right? Whatever that line, we call it as a zero air void line. And 95% saturation line and 5% air void lines are never, they are going to be same. See, the degree of saturation 95% means air content. You know, the degree of saturation plus air content is going to be 100%. So air content is going to be 5%. But they are not asking air content, they are asking the air void. So percentage air voids Na is equals to Na into Ac. Where N is porosity, the porosity will be always less than 1. Always less than 1 into 5, the value is going to be less than 5%. So you tell me now, if the degree of saturation is 90%, what about the percentage air voids? It should be less than 5%. It should be less than 5%. So, which means 95% saturation line and 5% air void line are not going to be same. They are different. They are different. Okay. So now, the process in which a stress applied to a soil causes densification as air is displaced from the pores. When you remove the air, that process we call it as a compaction. When you remove water, that process we call it as a consolidation. So from the given, so the answer is going to be the compaction. Next, sheaf foot roller is most suitable for compacting. As I already mentioned you, sheaf foot roller is for the clayey soils. So corrosionless soil, coarse grain soil, coarser soil. Coarser soil is nothing but whom? Clay. Right? Next, come to the consolidation. So the process of expulsion of air is a compaction, whereas expulsion of water is consolidation. So, but for the expulsion of water, it not only depends upon the, it also depends upon the permeability of the soil, because it takes a very long time. Ability to permeate in or out, that depends upon the permeability only, right? So compared to the compaction, consolidation is a time-taking process, and it depends upon the various factors. Now, there are various type of coefficients. The coefficient of the volumetric compressibility is. So when you apply a load, that's a static loading. There exists as the load is going to be taken. Initially that load will be taken by water. And with the time, the water goes out. When water goes out, volume decreases. And that load will be taken by the solid. The effective stress is going to be increases. Because when the load is taken by the solid, the contact between the solids will increase. So effective stress will increases. So for that we have various coefficients. Those coefficients are volume, coefficient of the compressibility AV, compression index CC, coefficient of the volumetric compressibility MV. What is the coefficient of volumetric compressibility? That's going to be proportional to the void ratio, inversely proportional to the void ratio, directly proportional to the coefficient of the compressibility, inversely proportional to the coefficient of the compressibility. So the relation between the MV and AV is equals to AV by 1 plus E naught. So if you see the relation over here, so MV is a coefficient of the volumetric compressibility, AV is a coefficient of the compressibility. So MV is directly related, which means, so here coefficient of compressibility is directly proportional to the coefficient of the compressibility. So inversely, no. Directly proportional to the quotient of compressibility. This is true. And whereas inversely related to the void ratio. So inversely proportional to the void ratio is also true. So from the given options, actually there are two answers are there. So when they give the question in examination, sometimes you can expect these two. So when you expect these type of things, you can opt any one also, you will get the answer. So from the relation MV is equals to AV by 1 plus E naught, the correct answers are B and C. Next, in general, consolidation of soil involves which of the following? Consolidation means expulsion of water. Okay, so it's not expulsion of air. Reduction in shear stress, no. Application of a static load and dynamic load. Dynamic loading means compaction, static loading means consolidation. So consolidation occurs under the application of the static loading. Okay, now which soil will take years and decades to undergo full settlement? Obviously, whatever the soil having a least permeability will allow the water slowly, which means it occurs at decades and decades. What is that soil? Clay. So clay is a soil which will take years of time. Okay. Next, a clay deposit suffers a total settlement of the 5. The total settlement means ultimate settlement of the 5 centimeters with a one-way drainage. One-way drainage means single drainage. Now, for the same clay with the two-way drainage, the total settlement is. So, for the same clay, sir, one way it is going to be 5, two way is less time. So, the total is going to be 2.5 centimeter half. No. Look, whether the provision of single or double, that changes the time required to cause a settlement, but not the final settlement. Ultimate settlement is independent on the drainage conditions. Ultimate settlement SF is independent on drainage conditions. So don't expect the ultimate settlement is going to be dependent on the drainage conditions. It is independent on the drainage conditions. Whether it is a single drainage or double drainage, the answer is going to be same. So the correct answer is going to be 5 centimeters. Okay. So these are the level of questions we can expect in the consolidation. Apart from this, what you can expect from the consolidation chapter is, so they will be asking you the equations of the AV. What is the equation of the AV? Change in void ratio by change in stress. They will be asking the equations of the CC. What is CC? Compression index. So the compression index is nothing but delta E by log base 10 final stress by initial stress. Final stress by initial stress. And you know the MV also there. Apart from that, there is one more relation, quotient of consolidation, whereas CV is equals to K by MV into gamma W. And you can expect one more question, right? So you see in this question they are asking about the ultimate settlement. Sometimes they will be asking about the time. Look, there is a relation between that time. So the time required for the single drainage is always 4 times the time required for the double drainage. For single drainage, if it take 1 year, for double drainage, it will take 1/4 of that year. Okay. So that's one of the questions that we can expect. And apart from this, they can ask you the questions based on the stress history, NCC, OCC and UCC. What is NCC? If the present stress acting on the soil is more than the past and soil is consolidated under the present, we call it as NCC. And when do you say OCC? If the past stress is more than the present, then we can call it as a OCC. And what about UCC? If the soil is still undergoing consolidation, UCC. So in order to differentiate whether it is NCC or OCC, we have some ratio known as a over consolidation ratio. If the over consolidation ratio is equals to 1, we call it as a NCC. If the over consolidation ratio is greater than 1, we call it as a OCC. So these are the things regarding to the consolidation as per diploma level. I am not going too much into the derivations or numericals. So based on the diploma level, these are the type of questions one can expect. Now coming to the last topic, bearing capacity. So in the case of the bearing capacity, again basic level of questions only. So in bearing capacity also we need to we have to look into what are the different type of failures: general shear failure, local shear failure, punching shear failure. And when we design a foundation, we have to design that for no shear failure and no settlement, not no settlement, no excessive settlement. For that we have some bearing capacity factors. We have some soil bearing pressures, and then how to determine the ultimate bearing capacity by means of the Terzaghi's theory. Okay, so you see here the net loading intensity at which neither the soil fails in shear nor there is a excessive settlement determined to the structure is known as. What is the net loading intensity? Net pressure for neither soil fails in shear nor settlement. That is nothing but net allowable bearing capacity. So this is allowable bearing capacity, safe bearing capacity, net safe, ultimate bearing capacity. So ultimate is not going to be happen. Ultimate depends upon only shear. Net safe and safe bearing capacity, they also depends upon the shear. So allowable bearing capacity, actually it should be net allowable bearing capacity because they have given the net loading. The correct answer should be the net allowable bearing capacity. But anyways, when they mention shear and settlement both at the same time, we have to represent the allowable. The correct answer is option A. Now, the minimum gross pressure intensity at the base of foundation at which the soil fails in shear. Baba, minimum pressure at which soil fails or maximum pressure up to which soil does not fail. That is nothing but the ultimate. Ultimate means maximum pressure that soil can bear without any shear failure. Suppose I am a soil I am going to fail at the 100. What does mean by 100? That is the minimum pressure at which I am starting to fail, or the 100 is the maximum pressure up to which I don't fail. So the minimum gross pressure at base of footing when the soil fails is nothing but the ultimate bearing capacity. Next, the net loading intensity at the soil, neither the soil fails. The same question which has been repeated. Now, if the water table is likely to permanently remain at or below a depth of sum of the depth and width of the foundation. What is the meaning of that? If this is the foundation is located at a depth of D. So what they are saying is, if B is the width, if the water table is located at a depth of sum of depth and width, which means, so now this is B, water table is located like this, water table is located over here, or if the water table is located there, our effect of the water table is up to D plus B only. If the water table is beyond D plus B, there is no effect of water table. We don't need to do any correction for the water table. So what they are asking is a water table correction used in the bearing capacity equation. What is the water table correction? 1. Okay. And if this water table would have been raised to the ground level, then entire soil is under submergence. Then what is the correction factor we have to use? 0.5, which means when water table rises up to ground level, especially in cohesionless soil, bearing capacity reduces by 50%. The correction factor is 0.5. Now, in this case, there is no effect of the water table. Okay. If the soil has a very low bearing capacity and still, if piles are not feasible option, not feasible option means not economical. So then the best choice is for low bearing capacity, either we go for the in shallow rafter foundation or we go for the pile foundation. And it is still making that pile foundation is not feasible economically. So the correct one is mat or rafter foundation. Mat or rafter foundation. Okay. So the most reliable field test to determine the bearing capacity of a soil. The most reliable field test to determine the bearing capacity is a plate load test. Direct shear test is to determine the shear strength. Cone penetration test is to determine the skin frictional resistance. And so that is for the whatever the skin frictional resistance. And sounding test, that is a different term. So plate load test, the correct answer is going to be the plate load test. The plate load test is to determine the bearing capacity of the soil. Terzaghi bearing capacity factors depends upon. What is the Terzaghi bearing capacity factors? NC, NQ and gamma. They are depends upon the angle of internal friction. So from the given options, quotient of curvature, no. Angle of internal friction and depth of foundation, no. Uniformity quotient, no. Angle of internal friction of the soil only. So as we are discussing about the Terzaghi, as per Terzaghi, so he has given equation for the strip foundation. So what is the equation for the strip foundation as per Terzaghi is? So the ultimate bearing capacity QU is equals to cohesion effect CNC, surcharge effect gamma D and Q plus width effect is going to be 0.5 gamma B and gamma, where NC, NQ and gamma are the bearing capacity factors. And if it is a clay soil, in the case of the clay, first thing first, phi is 0. If phi is equals to 0, N gamma is 0, NQ is equals to 1, and whereas NC, as per the Terzaghi, it is 5.7, and if the base is smooth, you have to take it as a 5.14. So from this we can see if N gamma is equals to 0, if N gamma is 0, then the ultimate bearing capacity is independent on the width effect, because width effect is going to be nullified. 3 effects are there. This is for the strip. If it is a square, then you have to apply 1.3 before the CNC, and instead of 0.4, if it is a square, you have to use 0.4. So instead of 0.5, you have to use 0.4. If it is a circle, before CNC it is 1.3 only, but here instead of 0.5, you have to use 0.3. This is for square and this is for the circle. So that's the equation that we can expect. Okay. Now you see here, if two individual footings are too close as per the design, then they should be converted as. If two individual footings are too close, if the two individual footings are too close, then what happens? The pressure balls may get overlap. In that scenario, we always go for the combined footings. So the correct answer is going to be the combined footing. Okay. So now, as per Terzaghi equation, the bearing capacity of a strip footing on cohesive soil. So whenever I say cohesive soil, the phi is equals to 0 degrees. C is a 10 kg per meter square. For unit depth, D is equals to 1, and unit width B is equals to 1. Okay. So what they're asking about the bearing capacity. So what is the bearing capacity? QU is equals to CNC plus gamma DNQ plus 0.5 gamma B N gamma. Anyways, the N gamma is equals to 0. And moreover, they have not given anything regarding to the unit weight. So which means what they're asking is the net ultimate bearing capacity. In simple, the net ultimate bearing capacity for the clays is nothing but CNC. Why, sir? NQ is equals to 1, right? So the net ultimate bearing capacity, net ultimate is nothing but ultimate minus gamma D. So if you solve it, so CNC plus gamma D minus gamma D, and what is C? C value is given as a 10, and NC as per Terzaghi 5.7, so which is going to be 57 kilopascals. Out of the given answers, the correct answer is going to be the 57 kilopascals. If they give you the numerical from the bearing capacity chapter, they will try to give you from the clay point of view. Okay. Next, according to rank analysis, the minimum depth of the foundation. What is the minimum depth of the foundation? The minimum depth of the foundation is equals to Q by gamma into Ka square, where Ka is nothing but the quotient of active earth pressure. 1 minus sin phi by 1 plus sin phi. So from the given options, so if you observe, the option C is the correct one. So next, come to the last question. The plate load test is useful to estimate, as already discussed. Plate load test is for the what? Bearing capacity, and apart from that you can find out the settlement also. Bearing capacity, settlement, both bearing capacity and settlement of the foundation. The correct answer is option C. So apart from this, what we can expect from the plate load test is, in the case of the plate load test, the plate sizes are going to be varies from 30 by 30 centimeters to 75 by 75 centimeters. And whatever the size of the plate, every plate thickness is same, 25 mm. And when we are doing the plate, whatever the foundation we have to do, the digging, the trench digging is there, right? So whatever this width must be 5 times of the width of the plate. So the width of the foundation trench is equals to 5 times of the width of the plate. So these are some of the things, and when you are applying the load on the plate, the initial seating pressure you are going to apply is 7 kilonewton per meter square. And after finding the bearing capacity, we have to do some corrections for both bearing capacity and settlement, because plate load test we get the bearing capacity and settlement under whom? Under plate, not under foundation. So we have to apply some corrections also. So with this we have covered all the topics regarding to the diploma level, whatever the syllabus. So some of the students might be thinking there are some other topics like stability of slopes, earth pressure theories, shear strength. Mind you, based on the AE syllabus, those are not included. You can go through the topics which I have been covered over here. So far and so good. I have covered the basic definitions, basic formulas and all. Hope you understood this session, and all the best for your AE examination.